We're almost there. Now we're dealing with a geometric problem. And what I see here is a rectangle. And I've been given the area, so I'm going to start with what I know about rectangles. Area equals base times height. From here, I'm just going to substitute in given information. The area of the rectangle has been given to me as 36. The base, as I see it, is x plus 5. And the height is equal to x. Now, it doesn't really matter who you call base and height. It's interchangeable. Now what I'm going to do is the same thing I've done on the other problem. The hard part's done. Now I just need to distribute, combine like terms if necessary, get rid of this 36, set this quadratic equal to 0, factor and solve. Take a minute on your own, give it a shot. Press pause now. And this is what I get. I get 0 equals x squared plus 5x minus 36. And it doesn't matter what side you put the 0 on. Now I'm going to go ahead and I'm going to factor this out. So setting up my binomials here, leaving my 0 out on the left side. I got a negative right here, which means that I have opposite signs. X times x is going to give me x squared. Two factors that equal 36, and have a difference because these are different signs. Right? So this positive 5x is the difference of two numbers, and those two numbers would be, yes, 9 and 4. Since the 5x is positive, the larger number must be the positive number, and the smaller number is the negative number. Got my zero product property, so I take my two terms, set them equal to 0, solve, and I get final answers of x equals negative 9 and positive 4. Now before I walk away from this side, the goal wasn't to find x, the goal was to find the dimensions of the rectangle. Okay, so the dimensions of the rectangle are going to be x and x plus 5. Well, this negative 9 is not possible to be an actual dimension, so I'm going to throw that answer out. It is a 0 of the parabola that describes this situation, but that's not going to be useful for my final answer. So we're going to use a final answer of x equals 4. So the rectangle is a 4 by 9 rectangle. So our base is 9 and our height is 4. That's my final answer. And before I walk away, I just want to double check. Is 9 times 4 equal to 36? Yep. That's good because that was my area. So we're all set. Let's move on. Okay, another geometric problem. This time it's a triangle. Area equals base times height divided by 2, or if you want to look at it like area equals 1/2 times base times height. Whatever is comfortable for you. Now I'm going to go ahead and substitute in what I've been given. 42 was my given area, is equal to 1/2 times x plus 3 times 2x plus 8. Now, right here what we have is a situation on the right side where I have a times b times c. Now I could multiply the 1/2 times the 2x plus 8, that would work out nicely. Or I could choose to FOIL the x plus 3 and the 2x plus 8 and then multiply 1/2 times that. I'm going to go for that method. So 42 is equal to 1/2, and now I'm just going to set up sort of a big large set of parentheses. X times 2x is 2x squared, x times 8 is plus 8x, 3 times 2x is plus 6x, and 3 times 8 is plus 24. We're running out of room here, so plus 24. Okay. Now what I'm going to do is combine like terms and then distribute through by my 1/2. So 42 is equal to 1/2 times 2x squared plus 14x plus 24. As I multiply through by 1/2, I'm going to get 42 is equal to x squared plus 7x plus 12. Of course, we're going to subtract 42 from both sides. And I'm going to get x squared plus 7x is equal, I'm sorry, there's a slip up here. Gotta watch me, folks. Minus 30, and that's all equal to 0. All right, so now we want to factor that out, so we're going to get 0 is equal to, and now we're looking for our 30 is negative, so that's a plus and a minus. Two numbers that multiply to 30 and have a difference of positive 7. You guessed it, that's going to be 10 and 3. Since the 7 is positive, so is the 10. The 3 is going to go here. And that's going to give us final answers. I'm sort of going to skip that setting the zero product property. I'm just going to look at it as the zeros of the function, or the roots. X is equal to negative 10 and positive 3. Now again, if I use the negative number, I'm going to get negative length, so I'm going to toss out the negative number this time. I don't always automatically toss out the negative. I toss out the one that would give me negative lengths. In this case, it is the negative number. So my height is going to be 3 plus 3, because x is equal to 3. So my height is equal to 6. And my base is 2x plus 8. So 2 times 3 is 6, plus 8 is 14. Okay, well, I'm going to circle this or square this up, box that up as my final answer. But just, is 1/2 times 6 times 14 equal to 42? Well, 1/2 times 14 is 7, and 7 times 6 is 42. So, yep, that seems like a good final answer to me. Last problem of the video is basically the same as the other word problem, only this time we didn't provide the drawing. So you're going to have to work with me on the drawing. So it says a city skate park is a rectangle that's 100 feet long by 50 feet wide. So draw a rectangle. It's 100 feet long, 50 feet wide. All right. And what they want to do is they want to triple the area. Well, first, how about we calculate the area? Now, I know that they use length and width. I prefer base and height. So 50 times 100 gives us 5,000. And technically that 5,000 is square feet. They want to triple that area. So 3 times 5,000 would be equal to 15,000 square feet. That's going to be our new area. Okay, now I'm getting a little ahead of myself. If I go back to the reading here, it says that they want to add, right, in order to achieve that 15,000, they want to add the same distance, x, to the length and the width. So what we're going to do is we're going to extend this side and extend this side so that we get a new park. And this is going to be x, and this is going to be x. So x plus 50 times x plus 100 is equal to 15,000. So you guessed it. Foil that out, subtract the 15,000, combine like terms, all the hoo-ha, set this thing equal to 0, factor it, and get an answer. Press pause now, try it out. So after combining like terms and shifting the 15,000 over, this is what I end up with. So now we need to factor this x squared minus 150x minus 10,000. And again, don't let the big numbers fool you. We're essentially looking for, if we ignored the zeros, thinking about like 115 kind of thing. And so why not go for the old 2 and 5, but not 2 and 5, but 250. They multiply to 10,000. They have a difference of 150. That 150 is positive, so I'm going to have my x plus 200 and my x minus 50. That seems to work out nice. We're going to get x equals negative 200, positive 50. Again, striking out the negative number because x is an actual length, so x can't be a negative number. So we're going to have 50 and 50 over here. So our new lengths are going to be 50 plus 50, which is 100, by 100 plus the 50 is 150. And when you multiply 100 times 150, you do indeed get 15,000. The only thing we need to add to polish up our answer are units. That's 100 feet by 150 feet. That's it. This last page is a series of problems that you need to have completed after you watch this video. So you should have the notes for the video and all of these problems complete. Thanks for watching.